what's going on with someone, what we do about it. So we can have a look at how the NeuroCatch helps to guide our clinical decision making, but also talk a little bit about what we're learning about how to treat the brain and how to get the best possible results. So without further ado, I'm going to hand over to Ryan, sorry.
Awesome. Thanks, Tanya. Yes, I think by way of introduction, I'm a neuroscientist, neuroimager, and big neuroplasticity geek, just like all of us. Did you want me to do a quick introduction of NeuroCatch as the slides up? Yeah. So yeah, for those who are familiar with NeuroCatch, I'll try to be brief. And for those who aren't familiar, I'll try to be equally informative. Basically, NeuroCatch is based on EEG technology. Specifically, it's an elevated EEG that extracts evoked potentials into a brain vital sign framework to allow for an objective assessment of cognitive function. And what we aspire to do with it is to make it as clinically impactful as possible in terms of neuro assessments. You can't treat what you can't measure. So NeuroCatch is designed to allow for a point of care available and tests that can be done in minutes that provides you with an objective assessment of cognitive functioning of the brain.
Awesome. Now, for some reason, my slides are not showing anymore. Are you guys seeing the slides still?
I see your slide. It just hasn't advanced to the next one.
Okay. For some reason, I think it's just the view that I have.
That's good now. Yes, we see it.
Great. Awesome. Now, for me, though, the odd thing is I am not seeing the slides myself. So I'm just going to change the view. Oh, there we go. Oh, it was there and then it's gone. Annie, I just see you for some reason.
Let's see here. Maybe under, I'm just at the top where you have,
you might want to stop sharing and then reshare.
Yeah, I think I might have to. Sorry about that, everyone. Just getting to know this particular new Zoom workplace version. It's different than what I'm used to using. So it'll take me a second. And the future ones will be much smoother. Okay, there we go.
Okay.
It's still not advancing for some reason.
Yeah, we see it.
It just appeared.
Okay. So, Ryan, do you want to talk a little bit about brain vital signs?
Yeah, absolutely. So we started trying to directly attack the problem of subjective measures of brain function in actually the mid 1990s by using electrophysiology and neurophysiology. And in neuroimaging, a lot of times, because we're non-invasively imaging brain activity from the outside and peering in, we're really driving at getting things more complex and more sophisticated in our measurements. The concept of brain vital signs was actually to try and do the opposite, to flip the perspective, if you will, and ask the simple question, why do we not have so much as a vital sign for brain function when we consider how impactful vital signs have been for example, for heart health and cardiovascular health? So we actually did undertake a bit of an adventure to try and understand how we could develop a framework based on what we knew of existing vital signs, and then take that through the scientific literature and demonstrate that could be possible, validate it, demonstrate it was repeatable, and then implement it as a medical device, which is basically the science that continues on now and applies across a host of brain conditions, starting in concussion and brain injury, moving into wider neurologic, mental health, and performance. And so that's kind of our vital sign framework.
Awesome. And as Ryan was saying, it's interesting to see that things haven't changed very much in the last several decades, and that a lot of the cognitive assessments that are out in the world today are very indirect with the MMSE and the MoCA, things that require you to touch a screen or react to something, and that can be very limited by your ability to have good motor control or sustain your attention for a period of time. So as a result of that, a lot of the tools that are out there in the world today are very imprecise You want to explain, Ryan, what it is about the NeuroCatch that makes it more valuable in terms of its accuracy and precision?
Yeah, for sure. So the essence of it is really around objective neurophysiological measure of cognitive function. But in order to do that, we really focused on the concept of a well-established scientific concept that's been in the literature for a while called event-related potentials. And actually, if you put in PubMed and search that out, you'll get over 160,000 papers that have been published. So this is a really well-established concept. And what we wanted to do is actually condense it and turn it into a medical device that would allow you to accelerate finding, not only to evaluate a patient at an individual level, but also to actually evaluate the effects of interventions and build that to be clinically regulated in terms of a standardized device that allows for normative data comparison. So in this case, a lot of people who are sort of wrapping their head around it, if it's new to you, they're thinking, oh, so you diagnose a concussion. And actually what we do is sort of the inverse. We do a really good job at looking at what normal cognitive profile looks like so that your individual patient, when you get a result, you can map that against the norm and look at whether or not they're in normal ranges or not. And this, I think, also just keeping in mind that the theme of the talk is around neuroplasticity. As I mentioned, you can't treat what you can't measure. So if you're going to try and harness neuroplasticity through interventions that guide that in a positive way, you want to really be able to have a sensitive measurement as to whether or not that's having an effect or not. And that's the heart of where the NeuroCatch platform is driving our therapeutic efforts towards neuroplasticity.
Absolutely. And the neat thing about the NeuroCatch is that it's, as those of you that are using the NeuroCatch already know, it's relatively simple to deploy. So you've got a cap on your head, you've got a laptop beside you, you've got a device that helps to filter out noise and make it more accurate and precise. You've got earbuds in your ears, and basically you run a sequence that runs for just over 6 minutes that generates some cognitive measurements, and it produces a report within 2 to 3 minutes of the test being completed. So we'll talk a little bit about what the 3 vital signs are. And Ryan, I've just got the cognitive hierarchy up here. So do you want to just chat through the 3 ones that are so well studied that we chose to focus on for our particular test?
Yeah, for sure. So we sort of treat your brain as a supercomputer in terms of that metaphor. And we want to understand information and cognitive processing from the low level sensory processing to the mid-level basic attention processing to the highest level cognitive processing. And so what we've really done is looked at what are the top neural responses that we can ping your supercomputer with a basic combination of low-level sounds and also word pairs that invoke cognitive processing, information processing, and memory. And that allows us to get these 3 responses and then find for an individual patient if those 3 responses in terms of both their size and their speed map into a normative range.
Exactly. So what the client will experience is a series of sounds like beep, 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 followed by a louder beep, then word pairs, some that are matched like dog or cat, salt, pepper, and then some that are mismatched, pizza, bed, or pizza mountain, or something like that, that is a violation of what your brain is expecting to hear. And then through EEG and the ERP waveforms, we can actually identify how quickly your brain is responding and get some measures of different aspects of your cognition along the way. And so, for example, when you get to the word pairs, not only does your brain have to recognize the sound that it's hearing, it has to actually be able to place that sound in the context of a word. Then it has to go back through your memory to decide, how do I know that word? Where do I know it from? And does it match or not match? So by the time you're getting to the word pairs, you're actually measuring a fairly high level of cognitive function. And so, from the sensory processing, which is just the sound hitting the eardrum, all the way up to these complex functions, it's wonderful to be able to get such a precise and sensitive measure over such a short period of time. And, in Ryan's past life, where he was running huge imaging labs, it may be that people would be coming in for an EEG that would be several hours and stuck in a lab somewhere, and then they would get a report that really wouldn't be that valuable or insightful in terms of helping them to make clinical decisions. So this has come a long, long way. So as Ryan said, event-related potentials have been studied for close to 100 years, and they've been proven to be sensitive to lots of different things going on in the brain in terms of being a biomarker. So we'll talk more about that as we talk about neuroplasticity and what you might expect to see in some of these conditions. But dementia, mental health disorders, acquired brain injuries, concussion, TBI, stroke, all of those things have unique patterns of electrical activity that can show up on a NeuroCatch scan. And one of the benefits is that it's, a sixth of the time and a fifth of the cost of an MRI, for example. So we're looking for ways to be able to look at cognitive function over time and comparing someone against their own scan and looking at how we can make changes to the brain. So this particular story, I think, is a really interesting one. And I'm going to let Ryan tell you about Captain Trevor Green, because it was probably one of the most compelling stories we've ever had through the clinic, and continues to be ongoing today.
Sure, and you might be wondering why Tanya and I in a neuroplasticity talk are talking at the front end so much about NeuroCatch, but this slide really does make the point. And many times a good story starts with the ending first. And so this is actually Captain Trevor Green, who was in Afghanistan, and in 2006, a young man came up from behind, and as he was leading an age-old shura with the elders, where they take their helmet off and lay their firearms down, this young man pulled out an axe, and with all of his might, drove it into the top of Captain Green's head, so deep that he transected the body of the corpus callosum. And in Trevor's words, as hard as and with the effort that he was splitting a log. So this is probably unofficially the largest surviving brain injury that we know of on the planet. And what the slide shows is actually the ERP, or the neurophysiological results, turned into a vital sign, where you can see that over the course of intensive rehabilitation, Trevor still had, on the sort of left-hand side, attentional impairments. Where the injury had impacted a lot of attentional areas in his brain, like the cingulate gyrus. And so while we were giving active physical therapy, we were also getting NeuroCatch scans of his cognitive processing, and we couldn't see any real improvement in his cognitive attentional processing. And then we actually did 14 weeks of a neuromodulation neurostimulator called the PONS device, which facilitates neuroplasticity. The interesting clinical observation here is that we were focused on basically largely PT and OT goals. So we were really testing for his ability to stand and maintain independent standing. And we saw huge clinical improvements, even in a 20-minute stand test. He went where we just give physical therapy alone and could only stand about 2 to 3 minutes independently, to when we actually combined that with this neuromodulation, and quickly he began to ceiling the test and could stand independently. What's interesting about this slide is concomitantly, we also saw improvements in his attentional function. So over the course of that 14 weeks, you can see actually he normalizes to the right and regains the activity in his brain for attentional processing. And what was really quite interesting is that while we were treating for PT, we were getting cognitive impacts. And at the same time, actually, both he and his wife reported dramatic drops in his PTSD. And he has severe PTSD characterized by night terrors. And all the night terrors have subsided, and they've actually stayed that way since. So this is quite a remarkable case, because it shows that there's quite a downstream impact of neuroplasticity in the clinics when you're focusing on treating with innovative treatments.
Agree. And Ryan, would you mind describing to the group how the radar plot works, about what it means when you have a smaller plot versus a larger plot?
Sure. So we talked about these 3 responses of your brain as a supercomputer, with low-level auditory sensation in sort of the top right-hand corner. And then as you move around clockwise, you get to basic attention, and then continue moving around and you can see cognitive processing. And these are basically elicited brain responses. So because they're a waveform, they have both an amplitude or a size and a speed for their peak. And so 3 times 2 is 6. And so we have 6 main points that form on a radar plot. And as you get more brain activity and those responses get faster, you will move towards the outside. By contrast, when we look at these in people who are in stage care homes for dementia, we see that those responses tend to shrink towards the center. So what you can see in this is actually Trevor regaining his attentional processing in basic attention in the size of the response of the P300.
Yeah, it was a pretty dramatic case, and it was exciting to see the changes that he went through over the period of time that we had him in a rehabilitation program, and probably one of the most dramatic cases of neuroplasticity I've ever seen. So we can talk a little bit also about how ERPs kind of show up in aging of the brain and what you might expect to see as someone comes into your clinic that is getting more advanced in age and struggling with any kind of attention, concentration, falls, that kind of thing, what you might see on a scan in that situation.
Yeah, so now if you look, you see the radar plot in the top right-hand corner. And this was a study where we validated by looking at 2 groups of healthy individuals, both younger adults and older adults, to demonstrate the responses in the radar plot format, to demonstrate that they are across the lifespan, and to show you, just to get you familiar with the actual neurophysiology. So the waveforms themselves, we record them on the horizontal axis, that's about a second. So basically, we stimulate the brain multiple times, and then we create this average neurophysiological response that's measuring responses in the millisecond. So these are very fast. And you can see that the responses in terms of early on time is this N100 sensory response. Then a little later is this P300 attentional response. And then to different stimuli, to the word stimuli in the center of the graph, is when we give you something like the day of the week and we either match or mismatch with your expectation. And that's your cognitive response to the mismatching incoming word pair. And so what these show is that we get these in all individuals quite reliably, and they do subtly differ as we age. So we do know that as you age, our cognitive processing does slow. And this is demonstrating that NeuroCatch is sensitive enough to detect the cognitive slowing in healthy aging. And when we give you standard subjective tests, such as the mini mental state and the MoCA, those are not sensitive in detecting healthy cognitive aging. And so again, it's invoking the whole concept that once you can sensitively measure that, you can keep people in a healthy cognitive aging place. And there are lots of interventions and treatments that can activate neuroplastic mechanisms to actually help counter the aging effects. And that's one of the things that we're looking at quite actively now.
Absolutely. And as you could see from the prior slide, as people age, they tend to collapse a little more in towards the center as things slow down. And often what happens is they're using more, it's taking more work in their brain to do the task that they're doing slower. And we won't linger on this one for too long, except to say that when people are at the very end of life in dementia, you'll see this really dramatic collapse in towards the center. And this is certainly what we're trying to prevent. Ryan and his team just published a study not long ago, a few months ago, related to this population. We're doing a lot of work in the cognitive aging space, helping people generally with falls and fall prevention and cognition longer and later into their years to keep them healthy and in the community much longer. And there are 2 particular things that are I think salient when you're talking about fall risk. One is hearing, auditory perception starts to decline, and that's often associated with fall risk, and cognitive processing speed is also associated with fall risk. So 2 of these measures that we can get on the NeuroCatch are actually directly impactful in that particular patient population. We'll talk a little bit later about how we design programs around that and use what we learn about neuroplasticity to really amplify the results. So I'm just going to skim through these quickly. So in neurological disorders, you'll see where the tick marks are, that ERPs or that this particular measure that we're using are affected. So Alzheimer's is affected across all 3 domains, MS for sure in 2 of the 3, and there's ongoing research. Wherever you see a TBD, there's research ongoing to identify exactly how the brain waves change in response to these types of insults to the brain or neurodegenerative conditions. And certainly with mild cognitive impairment, we're getting closer and closer and closer to looking at the specific changes that happen. Sometimes if it's a TBD, could be that there's conflicting research. Other times it might just be that there isn't enough to make a conclusion, but our lab is constantly working on ways to get this chart more fully filled out. And we're looking for help through our Brain Innovation Network to have extended clinical partners and clinics all over the world feeding data to help us get answers to these really important questions. And the same with mental health conditions. As you can see, post-traumatic stress, anxiety, depression, schizophrenia, bipolar disorder, OCD, phobias. And we're really seeing a lot, and we'll talk a bit more about this later as well, around PTSD and anxiety really showing up in the P300. And I'll show you some samples of scans. So this particular clinic is in Ottawa. It's a physician who does a lot of work with veterans who have pretty extreme cases of PTSD, chronic pain, and all kinds of other things. And what he has started to notice is a very characteristic pattern that emerges with PTSD, where the N100 amplitude, so your sound sensitivity, is much higher, as well as the amplitude for your P300s. You're exerting a lot of cognitive energy to do things. And in many cases, you'll see that the latency, which is the speed, is slower, even though the amplitude is higher. So you're using more of your brain, or you're more sensitized in those situations where your amplitude shoots through the roof because your body is so sensitized to those stimuli. And then you'll notice the latency is, dropping down more towards the center. So it's less efficient in terms of time. And that can cause a host of problems for the clients that we see, as many of you who are clinicians know. So the other really cool thing is that because he has people typically for a half day or a day, he's doing more independent medical exam stuff. He often will take a measure at the beginning of the session, then again at the end of the session. And the scan on the left-hand side demonstrates exactly that. So these 2 scans were 2 hours apart. And what he focused on in the 2 hours between the scans was helping the person to calm themselves, feel safe in his presence, and using things like compassionate inquiry and other kinds of things to help settle the nervous system down. And what you'll notice is that the green line starts to drop inward. And in terms of the amplitude, which was unusually low, it actually started to bring it out more to the normal level. So his brain started to respond more and be able to give more resources towards cognitive processing because this person was less agitated. So it can go the other way sometimes as well, where someone is recounting a very traumatic memory and it actually spikes them up more. So he can tell the efficacy of what he's doing by the impact that he's having on the scan result, and starting to identify what things work for people and what things make them worse. So it's been a really interesting exposure for us to be able to have these great conversations with him about what he's using in his clinic to help move people in the right direction.
Yeah, and what I would jump in quickly and just note that with being able to look at the neurophysiology of PTSD in the P300 as an arousal circuit, it really does drive home the point of the underlying role of neuroplasticity, because neuroplasticity is an innate capability within us all, because effectively it means we rewire new circuits. And it can act and operate either for adaptive purposes, like in physical therapy and rehabilitation, that's what we're really driving at, or it can act in maladaptive, when you've seen been exposed to something, and then your circuits have wired to be reactive and highly aroused to them. And so in essence, when you measure these things, as Marcus's data are showing, it allows you to start to actually utilize clinical practice to guide neuroplasticity in a direction, rather than allowing it to just maladaptively impact an individual in a way that we all too often know.
Exactly. And you'll notice on the second scan, actually, the high N100 corresponded also to hypersensitivity to light and sound. And when we're looking at concussion scans, which look somewhat different from this, it's really interesting to see as people start to get sound sensitivity starts to settle, you'll see that N100 amplitudes start to come down and the latency start to come in line as they start to heal. So it's a beautiful way to be able to monitor how people are responding to treatment as well. This is another example, and again, quite different. So rather than these huge amplitudes, when people have had chronic pain for quite some time, they tend to kind of dampen their response to everything, and you'll see them start to collapse in towards the center of the waveforms as well. And so in the course of treating them, helping to improve their amplitudes and their firing synchrony and get comfortable with different stimuli and those kinds of things, you'll often see those things start to normalize as well. But again, each type of scan looks quite different. So we're going to just shift from the scans themselves into some of the basic principles of neuroplasticity. And those of you that are working in the neuro world are probably very familiar with Kleeman Jones, who put out a paper in 2008 going through the 10 principles of neuroplasticity. So we're going to quickly go through the 10 kind of core ones, but then I've added another 10 that are based on what we're finding in our clinical research and in our neuroplasticity clinic at NeuroPeak, of the things that are actually helping us to amplify the results that we're getting using these principles, but also some other research that's emerging. So the first piece is pretty straightforward. It's use it or lose it. We know that neural circuits degrade when they're not used regularly. And so one example of that are when they do sensory deprivation studies where unused neural connections weaken, and same thing when you're using like a limb through a stroke that's been immobilized for a long period of time, you'll notice that, yeah, at the beginning, sometimes you get a bit of movement, but if they're not actually strengthening that over and over and over again, that it tends to degrade and get more and more weak, or they go more and more into a spasticity pattern or more into the pattern that they're using most frequently. The second thing is use it and improve it. So engaging in targeted training can certainly strengthen neural circuits. And there are ways to actually even amplify this even more by adding novelty and play and all kinds of other stimuli that help your brain kind of lay down that memory or that cognitive processing pattern. We'll talk about some of those tips and tricks as we go. There was also some research on motor training in monkeys and rats that showed an expansion of neural representations in motor areas with specific training. And there was also some really cool research that happened on taxi drivers in the UK, where they actually found that the taxi drivers that were not using maps but using their brain to remember where to go had more cognitive processing space dedicated to the circuits around maps and mapping. Same thing with playing an instrument or using a particular skill over and over and over again. You actually dedicate more real estate in your brain to those tasks over time with practice. Specificity is another one. So training outcomes depend a lot on the nature of the practice. And one of the things that has been particularly challenging in the brain world is things like brain training. So there are literally thousands of different brain training programs out there. And there was a research review done a few years back where they were looking at things like Lumosity and some of these other game-based brain training things, and they found that actually it had very little transferability into activities of daily living. What would happen is that you would practice that game and you would get better at that game, but it didn't transfer over into other things that were also important. So the more effective games, people like Brain HQ and Cognifit and some of these other programs that are out there now, they're being more thoughtful about how they're designing the brain games so that they do have more transferability, and that is slowly starting to improve. But you want to be careful when you're looking at different brain training platforms to make sure that there's a level of specificity, but also a level of transferability over time. So the more you work on a particular task and the more specific you are with it, the better it gets, like playing a specific instrument again. But you want to also make sure that you're looking at all of the other features and what is it that you're trying to get at in terms of a functional activity. Repetition, of course, we all know this. There's a lot of information out about this whole idea that you have to do 10,000 repetitions of something to become an expert at it. They have actually debunked that to some degree, although it is crucial to do lots and lots and lots and lots of repetition. You may not need that many repetitions if you start stacking your neuroplasticity strategies together. So, you know, adding novelty, adding play, adding emotion, adding meaning, all these other things can help to shorten the period of time that you need to be repeating over and over. But basically, you want to make sure that you get enough repetitions of that activity so it becomes more automatic. Intensity is another key piece. So high intensity training is more effective for creating durable neural changes. And I would say that I have some real world experience with this, with the cases like Ryan was talking about, where we were doing neuroplasticity using PONS, translingual neuromodulation, which we can talk about later. But basically, it sends a current through the tongue, through the cranial nerves to the brainstem, and encourages remapping of that area, whether it's engaging other circuits around it or working around damaged area, or in some cases, you know, reigniting a neural pathway that hasn't been working for a while. But what we found is when we left clients to their own devices, where they were just doing their own gait training and just puttering along and just doing what they would normally do without really pushing themselves, they got some modest improvements. But as soon as we brought them into a rehabilitation setting where we were taking them more to the edge of what they could do, and consistently week after week after week, pushing the intensity, pushing the challenge level more and more and more, we amplified our results considerably. So I think in those early kind of clinical trials, we were getting 70-some% with, you know, significant improvement. And now that we've kind of figured out the right intensity level, we're up in the 80 and 90% results now. And I think that it's simply from really being clear on how much challenge was required to get the best possible neuroplastic change. And there's obviously the time that you implement something early versus late, and the timing of it. And in this whole idea of timing, we're also going to talk later in this talk about how we sequence things. So for example, you know, obviously you want to get to somebody before too much maladaptive neuroplasticity sets in, or before too much weakness has come along, while their brain is still, you know, active and firing in the pathways that you want to strengthen. So getting in early is really, really, really important. But then the other thing is that actually sequencing things in the right order. So for example, in our seniors health program, we get them to do exercise at the beginning, so they get some BDNF release and get their system kind of primed and more alert and more activated. And when we do that, we find that whatever we put after that in terms of a clinical activity for motor learning or cognition, they tend to do better in. And then salience, which is really how meaningful or important is this particular rehab activity to the person. The more they care about it, and the more you can tie it to something that's important to them, the more likely they are to have a positive experience and lay down that consolidated memory of that motor skill or that cognitive skill. Age. And they used to, I think that we've kind of upset the apple cart a lot in this way. You used to always say, you know, once you got sort of past a certain age, it was hard to teach an old dog new tricks, but there are some beautiful examples of neuroplastic change well into the 80s, 90s, and even hundreds. It may take more repetitions, and it may take a little bit more intensity to be able to affect the same changes in someone who's older, but it's still entirely possible. Then we talked earlier a little bit about transference, the ability to generalize the skill sets. So you want to make sure that, for example, if you're wanting to help someone get back to driving, as an example, that the brain training tasks that you're doing link in some way back to driving, so that you can transfer them over and ensure that people are getting a wide range of activities, whether it's motor, oculomotor skills, whether it's, you know, a certain pattern of behavior with their hand movements, whether it's scanning the environment, and whatever the case may be, you want to add as many of the small skills as you can and stack them together and make them intense enough that they really lay down the signals. And actually, there was a really interesting study that I read a while ago. I think it was Brain HQ, related to driving, where they were working with people who had lost their driver's license. And in most cases, you know, people don't usually get their driver's license back. But because they were so skilled at stacking the neuroplastic changes together that they needed to see, they actually were able to get a lot of those people driving safely again. Okay. Interference. So this is really about maladaptive neuroplasticity. So previously learned behaviors or bad habits can interfere with new learning, highlighting the need to address maladaptive habits during rehab. And this is one of the reasons why getting in early before too much, bad habits have formed can make a really big difference in somebody's ability to overcome a challenge.
Yeah,
All right.
Tanya, I just want to jump in on the interference. We often commonly know that, let's say in rehab from stroke, where there's a lot of neuroscience on transcolossal inhibition, preventing those capabilities, and certainly actually in the case with Trevor Green, we actually imaged that capability of interference across the corpus callosum. But one, I think, powerful clinical example of interference that's good to be mindful of is actually comes from the domain of pain.
Yes.
So you can have a client who has chronic pain, and then through maladaptive neuroplasticity becomes increasingly sensitized, so much so that they could even imagine or visualize the stimuli causing that pain and feel that pain. So I think that's one of the best examples of maladaptive neuroplasticity working against treatment goals. And so often you have to think almost dualistically about what's happening with this person. Are they being interfered by neuroplasticity? How can I help them unwind that and wind into a positive trajectory of these capabilities? And I think that's exactly at the core of where now in today's day and age neuroplasticity is really frontline in leading edge treatment.
Yeah. And maladaptive neuroplasticity, I think, is a much bigger problem than was previously realized.
Yeah.
I think I see the same thing in people with attention deficit disorders or PTSD, where they've wired that pathway over and over and over and applied emotion and repetition and all of the things that drive neuroplasticity to drive it in the wrong direction, and sleep deprivation, all these other kinds of things. So one of the most powerful things actually in terms of our other concepts is this whole idea of growth mindset. So even if you can't do that thing now, imagining that you will be able to do that thing, even if you don't have that motor skill yet, or you're wired into a pain pathway or a high anxiety pathway, imagining and visualizing it being different, and actually imagining yourself doing that thing without anxiety, or reframing the anxiety in such a way that it feels more like excitement or anticipation as opposed to anxiety. So I've found that probably in my 33 years of being a physio, one of the most powerful drivers of positive neuroplasticity is this whole idea of a growth mindset. And there's some really great research done on this, and some good books written, like Carol Dweck and others, around growth mindset. And then there's some other ones by Angela Duckworth on grit, and growth mindset and grit kind of weave together in a really powerful way to help people overcome negative neuroplastic change. So I think that, often my very first session with a client, especially if they're protracted, or someone like Trevor who comes in 15 years after their injury and they feel like they've lost all hope, I find the first place to start is, what are we going to focus on? What kind of language are you going to tell yourself? What are the messages that you're unconsciously reinforcing, or self-limiting beliefs that you're unconsciously reinforcing in yourself? So even though I'm not a psychologist or a counselor, I think growth mindset, whether you're a PT, OT, or any kind of clinician, is one of the most crucial pieces that we can actually affect. And so I often start there before any of these other principles are applied. Meditation has also been shown to be an extraordinarily powerful tool in terms of reshaping brain regions and actually changing the morphology of the brain. So the hippocampus and the prefrontal cortex actually go through some significant changes in response to meditation. And it really enhances neuroplasticity by fostering a calm and focused state. One of the cool pieces of research, if any of you listen to the Huberman Lab podcast, there's lots of great podcasts on this. But in terms of motor and cognitive learning, the more alert and focused you are when you're doing a task, the better you tend to perform at it. I think that's actually one of the reasons that coffee for some people is very, very helpful, because it puts them in kind of a more focused, alert state, as long as you're not drinking too much of it and making yourself agitated. So meditation can be really powerful. And often what I'll do is at the end of a treatment session, before the person goes home, I'll have them actually just do a closed eye, quiet breathing activity. And when they actually did some of the studies on this, they actually found that if you do that at the end, especially at the end of a motor learning task, where they were doing a lot of the work, they were actually measuring the brain. And what would happen is the brain would fire in the reverse order of the task that was just taught. So if you're learning like a tennis swing, and you would start with the end of the swing, and then the different parts of your brain would light up in the backwards order. And then when you went to sleep at night and you were in deep sleep, it would actually run that whole program again in the right order, and you would be more likely to lay it down and recall it. So that's a really, really powerful and free tool that you can use anytime you want, and it will give you all kinds of great results that you would not get otherwise. What happens often is people rush from their rehab session right to their car, right into traffic, right into the next, to do on their to-do list, and you miss this meditation. And so one of the things that we do routinely when we're doing neuromodulation with people is before they leave the clinic, they have that 10-20 minute period of time where they just kind of close their eyes and let it sit. And we find the impact is really significant. The next thing is music. I had a beautiful case with a stroke lady where we were working on, it was crazy because she had trouble getting into the clinic. So I would go to her house on Sunday afternoons and we would do a little rehab program at home. And she was really having a hard time. We were doing neuromodulation, a bunch of other things, and she was really having trouble dissociating her body, like her hips from her pelvis, and just struggling with walking being very clunky and uncomfortable for her. And so I found out that her husband was a musician and they used to love to dance and do all these things. So I actually got him to make a playlist for me of all of the songs that they had danced to in the past. And as soon as the music came on, it was automatic. She just started to do the twist and to dissociate. And so instead of doing walking sessions, I would go to her house on Sunday afternoons and we would just dance. And the pace at which her progress grew after months and months and months of struggling with walking, it was absolutely astounding to me. So I think that, getting involved with things that affect the auditory cortex and the more kind of primitive brain areas, and then memories that are stored that are associated with emotions, they can tap into that meaningfulness and the specificity and all of these other things that you may not get otherwise in a more kind of controlled session. So I often use music, and the tool that I just picked up for our clinic is one of those silent disco 10 headset things, so that we could actually engage more music in, and getting family members involved in picking favorite songs and playlists, and and even creating like a state around music. So I would get them to pick their epic theme song where there's like Eye of the Tiger or something like that, just to get them really engaged and involved and getting into a certain state, which again is around that growth mindset. So music can often help unconsciously to drive those mindsets that you need in order to achieve maximum neuroplasticity, and also all the motor patterns that are associated with the music are powerful drivers as well. Neuromodulation, we talked about a little bit. Transcranial magnetic stim is very popular right now in treating depression and other kinds of mental health stuff. Direct current stimulation, again, another very promising treatment. They can enhance neuroplasticity by stimulating very specific neural pathways, and in particular in the mental health context, the areas around the hippocampus and stuff like that, and the amygdala. So there is some research that shows that using electrical current can help make the brain more receptive to new information. And we're going to talk a little bit about PONS, because PONS is an area that we've had a lot of experience with. I think at this point in time, our team has the most hours worldwide on this particular device. And it sounds corny. It looks like a popsicle stick, almost as wide, and has little copper bumps on the back, and sends an electrical current through the tongue, through the facial trigeminal nerves into the brainstem area. And you can see on this picture, you get this flow of electrical activity to the right dorsolateral prefrontal cortex, the dorsal anterior cingulate cortex, the left primary motor cortex, and a whole bunch of other areas that I think we don't even fully understand yet. There is a huge wave of activity that goes on in the brain. And then we pair the PONS stimulation with exercise, very, very, very specific exercise. So they do an hour in the morning and they do an hour in the afternoon. They do about 20 minutes. And this is my own preference. We do about 20 minutes of kind of gait and balance, but I like to do that first 20 minutes in such a way that we get their heart rate up a little bit. So they release a bit of BDNF into the bloodstream. Then the second 20 minutes is really specific balance exercises. So really challenging their balance system. And then the third 20 minutes is that meditation that I talked about before, so they can cement the motor learning. And over a 14-week period, we're having extraordinary improvements in gait and balance. And as you can see from here, another really interesting benefit that we get is some improvement in amplitude and cognitive processing, which, based on our conversation before about falls and fall risk, can really help with making sure that people are more stable and steady on their feet. And we have an upcoming talk with the person who is the medical director for PONS, who's going to teach us more about that neuromodulation in a couple of weeks. So that'll be an upcoming rounds if that's something you're interested in learning more about. Okay, psychedelics. This is an odd one, and we don't usually throw it into our neuroplasticity talk, but one of the cool things about being part of a brain health research lab is our ability to actually do clinical trials research. And one of the fastest growing areas for our clinical trials team in the last 6 to 8 months, and now for the next 2 or 3 years upcoming, is actually research on psychedelic assisted therapy, particularly in the mental health domain. But there's some really promising studies that are happening in different areas of the world on chronic pain, concussion recovery, and a bunch of other things. So I suspect in the next 5 years, probably a lot more is going to emerge about the idea of using psychedelics as a potential assist to the neuroplasticity process. And of course, there are lots of legal considerations. So it's not something that you can go out legally and do right now in many places, although there are some states in the US and certainly some research applications where people are starting to get legal access. But I think this is going to be a really tremendous area over the next little while, and feel free to stay tuned to our website for more information on how you might, or someone you know might join in a clinical study. Nootropics. So these are all the various kinds of supplements and brain boosting things. And unfortunately, there's just such a huge amount of information out there. It's hard to curate it all. And some of it is really accurate and has very solid clinical research behind it. And other things are more experimental, or they're making huge leaps in terms of what they're claiming versus what they can actually do. So I'm just going to focus on a few where we have a fairly good body of knowledge, and there will be a lot more information, I think, coming out again in the next 3 to 5 years as more clinical trials are being done. Blueberries certainly have been shown in several studies now to support cognitive function, and they predominantly think that it's because of their ability to mitigate oxidative stress through the polyphenols and a bunch of other different aspects of the biochemistry of blueberries. So berries in general, but blueberries in particular, are really helpful. Omega-3 is like a rock star. You definitely need enough healthy fats in your brain to help with all of the neurotransmitter functions, and also ensuring that the cell membranes are healthy and things are transmitting properly. So omega-3 is really solid. Lion's mane, and actually functional mushrooms in general. There are lots of studies that are coming out right now on cordyceps and chaga, lion's mane, turkey tail, and a whole variety of other mushrooms. But lion's mane is probably the most well studied at this stage of the functional mushrooms, and I think there'll be more to come in the next little while. Growth of basically those kinds of things, and there's lots of good compounds and variety of different vegetables and fresh foods. I think generally the consensus is things like the Mind diet and the Mediterranean diet, where you're getting lots of good, healthy, high quality fats and lots of fresh vegetables and fruits. tend to be stronger in terms of brain performance overall. And that is in the brain innovation topics. One of the things I really would like to bring a specialist in to talk about all of the various nutritional aspects of plants and different foods in order to help our brains stay healthy. And there's a lot of great research that's coming out all the time. Sound therapies, we talked a little bit about music, but there's also sound therapies like binaural beats and other kinds of sound frequency therapies that are coming out. There's actually a whole range of OTs that I met with recently that do a protocol called Safe and Sound, which uses different sound waves to help calm and directs different kinds of brain waves. And so I think there'll be more to come on that as well. And I've tried to give a reference in each of these cases, and I'm happy to share the slides later. But if there's a particular aspect of neuroplasticity that you're curious to talk about more, or research that you're looking for, please don't hesitate to reach out to me. I'm happy to share anything that I've got. One of the coolest pieces of equipment that we started playing with in our clinic this last couple of years is a chair called the shift wave chair. And you'll see it down in the bottom right-hand side of the screen. It actually gives pulsed pressure waves to deliver kind of whole body vibration. It stimulates lots of different sensory pathways. In some cases, this one doesn't, in particular, doesn't stimulate muscle contractions. It's more just a vibration. So it's kind of a pulsed pressure wave. It can enhance motor function and balance. Some of the ones that they're talking about, where they're talking about muscle contractions, are actually the platforms that people stand and hold on to. So they're in weight bearing, and the vibration actually stimulates muscle contractions and weight bearing. But the one that we've been fooling around with more in our clinic is one where you're actually laying back and it's going all up and down the body. You'll see it looks like a lawn chair with these big discs, these big metal discs embedded all the way up and down. And they have been fooling around with looking at how vibration impacts the nervous system. And there was quite a bit of work done in Santa Barbara and in California around vibration in the psychiatric community, actually. And the medical director of the shift wave chair is actually a psychiatrist. And so they were looking at how different patterns and frequencies of vibration impact the nervous system. And they found certain frequencies will upregulate your nervous system and make you feel more alert and awake, which for us in the rehab space, if we're dealing with people that are depressed or sluggish or have chronic fatigue or trouble focusing, that can be extraordinarily helpful before treatment to actually have them do an upregulating protocol. But more interesting was that they found a certain group of protocols down-regulated the nervous system, but really drastically. So they actually were doing blood draws before and after people came out of the chair, and they found that certain frequencies of vibration led people to very, very calm states, almost like they felt very sleepy. And when they did the blood draws, they noticed that the cortisol levels dropped into the toilet, but the immune biomarkers went way, way up. And so if you think about when that actually happens in real life, that is exactly what happens to you while you're in the deep sleep phase of sleeping. So they're doing some exploration now to see whether or not this technology is actually stimulating something called the glymphatic flush, which happens while you're in deep sleep. And for someone who's working in the brain health space, this whole idea of improving, perfusion and looking at stimulating more aspects of the recovery process at whatever period of time of the day they're getting into this chair. We're really interested in doing more research in this particular area to see if we can figure out what exactly is going on. But what we do know is that the veterans that we're using it on that have chronic pain and PTSD and a variety of other conditions are responding really, really beautifully to this chair. So, and there's also some really nice research that shows that it increases neurotrophic factors like BDNF, which again supports neuroplastic change. Vibroacoustic therapies. We're going to talk a little bit more about this, the red light therapy and some of the other things that are getting paired these days with red light therapy. We're just getting ready to do a clinical trial on this thing called the immortal chamber, where you actually lay inside this red light bed. It has near infrared and other wavelengths of red. It also has a vibroacoustic plate, so you actually are getting vibration through the body like the shift wave, although not at the same intensity. And then people are actually breathing nasal hydrogen through a cannula to help with metabolic health. And then they're actually doing breath work and meditating and doing all kinds of other things while in there. So I think there's like 5 different modalities that are paired into this chair, including a pulsed electromagnetic field to help with opening the capillaries and, generally getting more blood perfusion. So there's lots of cool things to play with. And we'll tell you more as we know more. So there's the bed and a better picture of the bed. And photobiomodulation, mostly the red light has been studied, but now they're actually looking at other frequencies of light. So I know they're using blue light to treat surface inflammation like acne and things like that. And they're using green light, which apparently activate the endocannabinoid system to treat pain conditions. So it basically, there's lots of different theories around why photobiomodulation is so impactful. But what they're saying is that it actually helps to regulate the expression and function of different neurotrophic factors, including BDNF and glial cell-derived neurotrophic factor and other factors that can impact neurogenesis and firing of the brain pathways and things. So I think this is another really promising area that's emerging right now. Novelty and play. So this is probably one of my favorite things. So whether it's dancing with people or making up, creative games to help them, use their balance system or use their coordination or do other things. I know we have Jen Based on this call. She has the Cognitive Function Development Institute in Arizona, and they are doing a ton of play-based neuroplasticity work with kids. And ironically, we're actually adopting a lot of their protocols to work with seniors, because often, once people get past a certain age, they don't get the opportunity to kind of have that fun and play and novelty. And we're finding some really beautiful results with their system as well. And then exercise, I would say, aside from really good sleep, exercise is one of the biggest factors in making sure that your brain stays healthy over a long period of time because of the BDNF release. So it enhances brain function, cognitive flexibility, overall mental health, fortifies the brain against cognitive decline. And so in particular, when you're talking about BDNF, although you do get BDNF release with strength training as well, it is extraordinarily powerful when you're doing aerobic activity. So we tend to put our aerobic activity at the very beginning of our treatment sessions to help really get some BDNF in the system while we go on to do the other tasks, because it's really a powerful driver of brain health in general, and also memory and emotional regulation, and all the other things that come along with a healthy brain. The other important part of exercise, though, is resistance exercise. And there was a huge systematic review with 43 studies in it looking at resistance exercise, actually, and cardio as well. But they found in particular resistance exercise was helpful for inflammatory markers in the blood. It actually kicked in fairly quickly, usually within a month. And then older adults with significant cognitive decline who did resistance training 2 to 3 times a week. These were people that were kind of on track to develop dementia based on their gradual trajectory of scores declining in the cognitive testing that they were doing. They found that after that 6-month intervention, 47% of them not only improved, but got back into the range of normal, which is very unusual to see. Usually once you hit dementia, it's a straight downward slope. And they were still achieving those results or maintaining those results even at the 18-month follow-up. So, and if you had to choose, because you only have so much time, what kinds of exercises to do, they found that greater leg strength was especially effective at improving cognitive performance. So, doing anything with big muscle groups that drives a lot of blood through tends to help, because, brain flow or perfusion is an important part. So we use our NeuroCatch device to look at all different kinds of treatment, everything from photobiomodulation to neurofeedback to shift wave to Immortal to virtual reality to psychedelics to PONS. So we are constantly assessing treatments as they're emerging, and we're excited to have a bigger group of brain innovation clinics so that we can gather information from all around the world and accelerate our progress in that regard. And then the last thing I'm going to do is just a quick case study. So this was a post-concussion case. A 46-year-old male was having lots and lots and lots of headaches, fatigue, visual challenges, exercise intolerance. And you can see in his first scan that his N100 amplitude was very low. His brain was just not responding very well. And the latency was really slow. You would expect with the N100 to see the spike around 100 milliseconds. So the speed of the brain's response around 100 milliseconds. So 116 is pretty slow, and he improved over a period of time with treatment to 104, and his amplitude moved right up into the normal level. With basic attention, again, improvements in the amplitude and improvements in the speed, and the cognitive processing is where we really see a big change. So he went from 552 milliseconds and with a target of 400, which is the N400, should be around 400, down to 446. And this is just kind of midway through his program, wasn't even at the end. This was just, you know, at I think it was probably about 4 weeks in. So yeah, it's really exciting to see what we can do. And this is just looking at the waveforms. And one of the features that I wanted to point out about this waveform is you'll see in scan 1, there's a big dotted line circle. And what the dotted line circle represents is the amount of variability in his brain response. So you can see there was a lot of width, which means that he had a lot of variability in the speed. And there was also fairly significant height, which means he had a variability in the amplitude. So the amount of electrical activity being expanded. When you look at scan 2, you see this beautiful tiny little ellipse that emerged. And what that shows you is that as the brain was recovering because of the neuroplasticity initiatives that we were using, that he not only did his brain response speed up and get stronger, it also got far more consistent. And I know in the rehab world, we talk a lot about heart rate variability. And up to this point, we have not really talked much about brainwave variability. And we think that that's a significant thing that's going to be emerging in the future. And fortunately, something you can measure if you have a NeuroCatch device. Same thing with this one. It did some narrowing of the ellipse, means that the speed was getting, the performance was getting more consistent over time. And then this last story was a great good news story that we had last year at the clinic, where there was a rugby player in Australia who is one of the top rugby players in the world, had sustained 4 concussions back to back over a 10-month period, and expected that his career was going to end, and was heartbroken about it because he's just an absolutely incredible player leading a strong team. And over the course of time that he kept getting concussed, his team was dropping in the standings, dropping in the standings, dropping in the standings. He flew to Canada. We took everything that we've learned about neuroplasticity and we threw it all at him. So he did the PONS, he did the nootropics that we recommended. There was a particular one that we like to use called Cinequel, which is made by Thorne. And it's like this cocktail of different supplements that are independently studied to improve brain health. So it was like, it had omega-3 in it. It had, branched chain amino acid, it had ketones and a whole variety of other things that were helpful. And then we did that specific sequencing of exercises where we did cardio, then we logged on motor learning, then we did the meditation, and he did absolutely beautifully. So this is, just to end on, this is the way that we sequence our programs. This is one that we do in particular for people with early cognitive and physical decline that are fall risk. So we prepare the body, so we make sure they've got enough building blocks for the neurotransmitters that they need, and we make sure that they're hydrated, because dehydration, if you are doing a scan or doing activities when you're dehydrated, it's like performing when you're drunk. It's very powerful when your brain is dehydrated in terms of pushing you in a negative neuroplasticity direction. Then we prime using a protocol to boost BDNF, whether that's cardio or whether it's shift wave or something else like that, if they can't do cardio. Then we have them perform brain training exercises. So we use Brain HQ, NeuroTracker, a whole variety of other oculomotor and brain training tools. Then we also use the non-computerized brain training, which is the game-based stuff that we learned from the team at CFDI in Arizona. Then we do a series of balance and agility exercises. We end with a meditation. And if they're struggling in any particular area, we assign them to a brain coach. And our brain coach will help identify what other features or factors might be playing a role and customize some treatment around them. So really, that's it. And I just wanted to open the floor if anyone has questions or stories they want to share, or tools that they found that are really helpful in their own practice. And just know that this is recorded, so we will share it with you after you'd like. All right, Leonardo, unmute yourself and feel free to throw your question out.
Hi, hello. My question was, how can the NeuroCatch device be used in American football and combat sports to help athletes in relation with CTE, and how could it be used in treatment to prevent negative changes in the brain as they age or as they continue in their career?
That is a beautiful question, and that's something we're actually working on with them. We do a lot of work in the sports community, in the preventions and treatment space to help athletes stay in the pocket of healthy cognition, and also using things like SynaQuell, using things like neuromodulation, tailoring their exercises, making sure they have the building blocks. And I'm actually going to let Ryan tell you about a recent project that we did in the hockey community with a supplement called SynaQuell, and what the impact was on protecting people from subconcussive impacts.
For sure. Yeah, it's a great question. We've been sensitive to detect basically in the subconcussive realm. So these are individuals that don't get a diagnosed concussion, but their exposure to concussive impacts accumulated over the season cause detectable and quite actually repeatable cognitive impairments in the N400 and actually some changes in the N100. And that's allowed us to measure, for example, Tanya mentioned SynaQuell. The Mayo ran a controlled clinical trial where junior A hockey athletes took this SynaQuell as a dietary brain protective supplement daily, and showed no subconcussive impacts relative to the control group that took a placebo control, which did show subconcussive impacts. So what we're doing now in terms of, I'm starting to conceptualize that subconcussive exposure to impacts is really, if you think of an iceberg model, is the stuff that's under the waterline that can cause, start to contribute to concerns with CTE. Of course, this is all hypothesis and theory, but what we're trying to do is manage, when Tanya mentions keeping an athlete or a UFC fighter or a military or otherwise in the pocket. If you don't do anything and someone is, if you think about how exposed to concussive impacts are they over a duration of time, we know that will actually cause cognitive impairment. So I've started to calculate kind of what is your concussive exposure, and then knowing that, I know about how far we might see them, for example, latency shift in the N400. However, once we benchmark them, we can do a lot to keep them out of that place and keep them in the NFL, for example, with the Miami Dolphins quarterback being a perfect example, very similar to what we saw, what Tanya showed with Kalen Ponga. You can keep them in a safer spot using a whole bunch of training that Tanya's nicely articulated here, and just keep benchmarking them and keep them out of that area. And that's been kind of one of the core areas that we're focusing on now for sure. And certainly from a healthy aging standpoint, I think from a longevity standpoint, all of this applies too, on a much more gradual scale, but similarly over the course of your lifetime. You want to be measuring and keeping your all these markers in kind of normal healthy range, and finding out which factors in an individualized point of view would work for you or for your patient.
Thank you both for your answer.
And I just saw a note about putting my last slide up again, so I'll just reshare that. And I see there's another question. E, please feel free to throw your question out.
Thanks. I actually got a couple here. Going back to the NeuroCatch test, you talked about benchmarking against the norm.
Yeah.
So who sets that norm? Where does it come from? Who owns that data? How's that data controlled?
Ryan, you want to answer that?
Yeah, I was going to say that sounds like a Ryan question.
Yeah.
So NeuroCatch norms are actually tiered. So what happens is, as a regulated medical device, the device always has very strict norms to strict sort of regulatory and otherwise quality-based capabilities. So every NeuroCatch scan that individual's data are actually mapped onto that norm. And in fact, right now, as we speak, we're renorming and adding more norms in that controlled way. So the short answer is effectively all scans go with that standardized norm. And in fact, we're probably, one of the things I like about that is our current normative database is actually also published. So we have peer review published normative data on the web. So it's not mysterious. You can go look at it in a publication, and that's all on our sites and open access publication available. But on top of that, because we've taken in the lab what would take 2 to 3 hours and be not clinically standardized, and we've condensed it, we actually collect layers and layers of interesting normative data. So we've done, for example, separate norms for hockey players. We're just doing ones for special forces in the United States right now. So we do have the capacity to actually then customize norms. And ultimately, what we're adding, what we plan to add to the software, is where you can drill into the norms and actually look at specific age ranges, or whether or not sex or different attributes, demographic attributes, to do more particular characterized analysis. But all of that is currently in or being built into the NeuroCatch software.
Awesome. Thank you. And my last question, and forgive me, I'm a little bit newer to all of this, but at some point, I think, Tanja, you acknowledged that people's auditory sensation declined with age. I mean, there are also people who are just deaf in the world.
Yes.
You know, auditory sensation is one of the things that you measure. Your test also seems heavily auditory based. So how do you accommodate for someone whose auditory sensation has declined? Because just because I can't hear doesn't necessarily mean my cognitive processing is bad.
Correct.
It just means I couldn't hear.
Yeah. So we went over it fairly quickly, but these 3 responses are actually you can get them in any modality. You can get them in auditory, visual, or even somatosensory. We chose auditory because it's the most rapid to deploy and most practical to implement clinically. We do routinely measure people who either have hearing loss, hearing aids, any sort of hearing component. And one of the interesting things that's come from that is exactly what you just said. You may well have some sort of, let's say, diminished capacity in your auditory channel, but yet actually it isn't necessarily given that you'll see a knock-on with the cognitive processing. So actually, more often than not, what we see is we might see some specific dysfunction in the auditory processing modality, but we actually will see that the brain plays catch-up and or compensates, and the P300 and the N400 are completely in the normal and rapid range. So it's got a quite a nice degree of specificity to those 3 responses.
Yeah, and I would just add that visual processing is also a little bit trickier to measure, in that it's harder to get distractions out of the way, and also there's a lot of emotional overlay that happens when you're looking at images. For example, if a picture of your mother goes by, or that looks like your mother goes by, then it kicks in a whole bunch of other areas and memories related to that can confound the data. So it's kind of the cleanest way for us to get clear data in a short period of time. But if there's any concern about that, we can also layer it with other tests. And one of the things I meant to say earlier that is crucial that I say now is that as a class 2 medical device, we are not making the claim that we are diagnosing anything. It's part of a battery of tests that help to guide your clinical decision making. It's not, we can't make any claims around that kind of stuff, nor would we want to, because we want to be able to look at cognition across a broad array of diagnoses. So one of the things I wanted to just make sure I clarify before we leave the call today too is just that it's designed to be part of a battery, and so you can always add different tests alongside it to help get a more clear picture, particularly if somebody has a sensory challenge or some aspect of the test they can't do.
Okay, so yeah, because my main concern was, if my auditory sensation is diminished, how can I trust all of the numbers if I have a hard time hearing the stimuli in the first place? But it sounds like you would recommend that clinicians do this alongside other potentially cognitive function tests don't do it in isolation.
In some
That-
situations, yeah.
Okay.
Yeah, that would be true. Did a couple of notes. One is the results are very much individual specific. So most clinicians find the power of NeuroCatch is in monitoring.
Yeah.
Because
Okay.
it's like your signature. So we don't concern ourselves too much. Like if you were to have a scan and you said, hey, I have tinnitus or I have auditory impairments and hearing impairments, we would still scan you because your result will be very much repeatable over time. So if, for example, we're interested in cognitive impairment due to dementia, that almost gets treated separate to whatever's happening at the N100. And the other important thing, just to note, we published where we did a head-to-head with the auditory version versus the visual version. So there are actually, you can get all three of these in visual. And we've published it and shown it. It's just as Tanja rightly said, it's just clinically simple to implement in the auditory modality. So we started there. We're waiting for people to say, okay, we absolutely need a visual. And truthfully, as much as we've had great conversations, we still, once people get using NeuroCatch, we haven't had somebody say, okay, we really need a visual. And that's including actually military, which we expected because of blast wound injuries and hearing, but we haven't had it yet.
No, as long
Well,
as they
thank
can
you.
discriminate between a softer beep and a louder beep, and as long as they can hear the words, even if they're soft, we still get a good read.
Mhm.
Yeah,
Awesome. Thank you. Appreciate it.
no problem. There was another question in the chat, Ryan, as well from Jeffrey, just asking if you could contrast the ERPs with or in the device like with brain mapping and QEEG and some of the differences between those two.
Sure. Yeah, for sure. So QEEG is looking at EEG. So EEG is just looking at the mass electrical activity recorded with sensors on the brain and then reducing it in QEEG into the frequency domain and looking at changes in the relative frequencies, alpha, beta, theta, delta, gamma, etc. That is really useful. So it's not to say that it isn't useful, but it's also very indirect. So typically it'll be a longer exam. You're going to put a larger array of sensors on. It's going to show you a map that says we've seen, in these areas, you've been in normative range, but in these areas, your ratio between these frequencies is out of normative range. And that tends to then indirectly relate to something. So the key to what I just said is there's a very indirect relationship between some adjusting ratio between, let's say, beta and alpha to cognitive function. In NeuroCatch, by contrast, we're evoking the stimulus response to processing sensory, attention, and cognitive information. So these peaks are directly related to cognitive, attentional, and sensory processing. So it's much more specific and sensitive to cognitive function and allowing you to understand what's happening with that individual patient's cognitive function.
Thank you. Any other questions? So I've put my contact info up. If you're interested in engaging in more of the Brain Innovation Network, if you have questions about any of the slides, or you want to dive deeper into a topic or bring a speaker in or be a speaker, we'd love to chat further. So feel free to reach out.
Oh, one further question. If you all did visual, have you done it with somatosensory too?
We haven't done the brain vital signs with somatosensory. They are, in fact, doable. In reference to the 160,000 papers, lots and lots of these papers have looked at these components in the somatosensory, all the way down, and thank you for asking, to being able to get the cognitive response with Braille. So they are robust in the somatosensory. We personally haven't done that and published that, but it is the case you can get all three of these markers in somatosensory, yes.
Thank you. Great presentation by both of you.
Awesome. I'm happy that you enjoyed it, and thanks for all the great questions. It's an exciting time to be in the brain health world, that's for sure. And we're looking forward to partnering with as many bright minds as we can. Thanks, everyone. And
Thanks, everyone.
Brainovation rounds are going to be on neuromodulation and the translingual neuromodulation, which we spoke a bit about today. And then we've got some other great upcoming speakers. We'll send out the list, and we look forward to hearing from you. Thanks, guys.
Thanks, everyone.